Hello everyone, welcome to our channel Code with Sunny, and in this video I will be talking about the problem subsets. Its index is 78 and it is the medium problem of the LeetCode. And yes, before moving on, I would strictly recommend you guys that if you are done with this one, it is the easier version of the next good problem, that is subset second. So like when you are done with this one, then you are going to visit this problem, solve this again. I've also solved this previously. You can see that yes, I've solved this today also. The date is 13th of February, and we I have already solved on 3rd of August 2021. Okay, so I would strictly recommend you guys that you should try both of these problems to understand how the variation is going to be done and how we are going to do that efficiently. So given an integer array nums of unique elements and return all possible subsets, that is the power set, and the solution set must not contain duplicate subsets. So we should report all the unique subsets that is going to occur in this array. And the one more advantage that we have is all the elements of our original array is going to be unique. Okay, and we have to return the solution in any order. You can see we have the array 1 2 3, and these are the subsets. An empty subset is going to be the subset of our array. Okay, and the max length of the array is going to be 10, so we can use a backtracking approach, and also you can use a bitmask also to represent the numbers. I will tell you all those. So first of all, let's move on to understand this problem with the example. Okay, so let's take a subset. Let's say we have an element called 1, 2, and 3. Let's say we have 3 elements. Okay, and let's find out all the subsets of this one. Subset means that we are going to choose the elements, like every possible case that we need to take it up. So let's say we are choosing a empty subset, so it will be containing no elements. Let's say and again we are going to choose the elements of size 1, that is we have an array of size 1, that will be a subset. So the possible cases are we can choose exactly this element, or exactly this element, or exactly this element. So there will be 3 subsets more containing exactly one element. So 1, 2, and this the last one, that is the 3. Okay, now this is the subset of size 1. So the next subset of size 2 would be either choose 1 and 2, or choose 1 and 3, or choose 2 and 3. Okay, so there will be 3 ways also. So you are going to choose 1 and 2, or you are going to choose 1 and 3, or you are going to choose 2 and 3. Okay, now you need to return the, also one thing I need to mention it over here is you can say that yes, I have chosen 1 and 3, right? So you can also say that I can choose 3 and 1, right? If you are going to choose 3 and 1, it is actually the same subset as of this one, because you can see if you rearrange 1 and 3, it would become if you rearrange 3 and 1, it is actually 1 and 3, which is matching with this one. And we need to return all the unique subsets. Okay, so you're not going to take this one, so only this one would be taken. So the next subset would be of size 3, so you'd take the all these 3, so it would be 1, 2, and 3. Okay, so these are the total 2 power 3 subsets that are going to occur. So how do you find out all these subsets efficiently? So the only one way would be used to backtracking. Use the approach of backtracking, where you are going to select this element and move further, or don't select this element or move further. Okay, so I'm leaving up to you guys to do the backtracking solution, but yes, I'll be explaining the efficient solution of this problem, and that is the use of Bitmask. Okay, so if you are facing problems in backtracking solution, you can mention in the comment section also. I would share my backtracking approach also. But first I would recommend you guys to try both these approaches. That is, the first one is the backtracking, and the second one is the Bitmask. Okay, like we are using the concept of bits to represent the number. Now okay, so just tell me one thing, that if you like, what is the size of this array? It is 3. So let's consider all the elements that are in the range 0 to 2 power 3. minus 1. If you consider all the elements in the range 0 to 2 power 3 minus 1, you have the elements from 0 to 7, right? You have these 8 elements. If you consider the binary representation of all the elements, it would be like 0. So let me write down, and 1, then we would have 2, then you would have 3. I think 2 should be this one. You would have 3, and you would have 4, and you would have 5 also. You would have 6, and finally you would have 7 elements. Okay, and let's fill out the remaining leading zeros to all those positions. Okay, now this is your binary representation for all the numbers from 0 to 7, like it goes up to the 7th number. Now consider, like if you focus over each bits of each number, it is actually representing the subsets. You can see, if this is actually, like if you consider, if any position of this binary representation containing the value of 1, that is this one, let's say this one, it means that for a particular this arrangement, we are going to take the position, take the element present at this position, because it is denoting that set bit is 1, like the bit is set. Okay, so consider this case. This case denotes that none of the elements is going to be taken, because everything is 0. So it actually denotes an empty set, which is also a subset. Now consider this position. It says that yes, I am going to take only the element that is present to the rightmost side, that is this element. So it is actually denoting that yes, I am taking the this subset, which is 3. Now focus over this element. Now it says that yes, I am going to take only this element, that is this element. So it says that I am be having a subset containing only this 2. Now let's focus over this element. It says that yes, we have these 2 elements being taken, that is 2 and 3. So it should be 2 and 3. And similarly, if you do over for all these elements, let's say we are going to be at the last element, it says that every element is taken 1 1 1. So you will take this one, and this one. It will be actually 1 2 3. This is also the subset of our original array. Okay, so what I'm trying to say is that whenever you have a certain number, or like certain number of elements, and every element is going to be unique, that is total number of elements in our subset would be 2 power n, we can always find out all the subsets by representing the every subset through a binary number. Okay, so a number is going to range from 0 to 2 power n minus 1. You can see 3 is the size of this array, 2 power n minus 1, and every number is actually denoting a subset of our original n size array. Okay, so this is what I am going to do. That also you need to understand that whenever there is a 1, it means that we are going to choose that element which will be included in our current subset. So this is what you are going to do. So this will be your answer containing an empty subset. Okay, and yeah, one more thing I need to explain, that yeah, I have used this different approach, okay, to find out the subsets. So the very first approach that I have used, let me show out you guys. Yeah, this is actually which is I'm talking about right now, the entire approach. So I will start my mask from 0, and it will go up to, you can see, 2 power n minus 1, and each time we will increment the mask, and this will store the answer. And yeah, I will take an empty vector right now, and for each bit which is set, I will check the set bit like this one. If the bit is set, I will push back the value into our current vector, and if all goes well, finally we will insert that current vector into our answer. This will return all the subsets. But if you notice over here that I've used a different approach, and how this is going to give us the correct answer, let us understand that. Suppose we have the elements called 1 2 and 3. We can generate the subsets iteratively also, like without any bitmask type of thing or backtracking type of thing. So we will always start with an empty subset, okay, which will be always included in our answer. Now let's try to fill out every element one by one. Let's say I am having the element 1. Okay, now when I am having the element 1, So what I'm going to do is like this is already included in our set, right? This is already included in our answer. Now when one comes over right now, it can always be appended to whatever the subsets that we have in our answer right now. If you're not getting it, let me repeat once again. Whenever a new element comes, we will always append this element to whatever the subsets that we have found till right now. Okay, so according to the definition, let's pick out this element 1, and whatever the subsets that are currently in our answer vector, we will append this one to their back. Okay, so this is already included in our answer, and we will append one to its back. So extra answer that will be gathered will be this one. Okay, so up to the element 1 we have two subsets, and it is giving the correct, which is actually 2 power 1, which is 2. That is if you consider only this element, you have an empty subset and the subset containing the value 1, which is 2 subset. Like total we have two subsets. Now consider that we are just having a new element with value 2. Okay, so according to the definition, what I am going to do is like our answer will be incremented by all those subsets which will contain the value 2. So what I am going to do is like with the value 2, append the value 2 to all those subsets which are found till now. So the subsets which are found till now is these two subsets. Will append the value 2 to these two subsets. So it would containing like when 2 is appended to this one empty subset, we are going to append it like append 2 to its back, so it would contain the only element 2. Again, yeah, we are appending 2 to the this back, this subset's last position, so it would contain the value 1 and 2. Okay, so you can see that if you consider only these two elements, right, you would have always have let's say you are going to find out the subsets. It would be an empty subset, subset containing 1, subset containing 2, and subset containing 1 and 2. You can see that yes, I have all these four subsets that are present over here. That is the demanded array is going to match with this one. And how this operation is going to work, according to the definition, whenever we have a new element, we would always append this current element to whatever the subsets we have found till now, because this new element should be appended to the required, like this new element should be appended to the all the already found subsets. Then we can have all these new subsets including the value 2. That's what we are going to do over here. Okay, so this is what we have, and let's say we are having a new element 3, so we will append the value 3 to whatever subsets we would have. So you will append 3 to this one, so it would be having 3. You would append 3 to this one, you would be having 1 and 3. You would append 3 to this one, you would be having 2 and 3. And when you append this one, you would be having subset of size 3, 1, 2 and 3. So now you can see our answer is actually this entire thing will be our answer, and this is actually the total number of subsets of the vector containing these three elements. This is what I am going to do over here. You can see this will store the empty vector, and whenever we will get out a new element, I will iterate to all those subsets which we have found till now. Note that Sz is actually the size of this answer vector, whatever the subsets we have found till now, and extract the subset. You can see answer of I, and push back the you can see the current element is actually num into the current subset, and yeah, this is our new subset. We are going to insert like push back into our answer vector also. This is what I am going to do. So talking about the time complexity, you can see generating each subset, like total number of subsets is 2 raised to the power n, and yeah, each time we will be having placing for each n elements, right? So like each n elements we are going to do that, and total number of subset is 2 power n. So you would be having n into 2 power n as time complexity, and space complexity is just for the total number of subsets, which is 2 power n. You can also understand the time complexity in a different way also. Suppose you have this solution which I am talking about, the very first one. Both have the same time complexity and space complexity. You are generating each element, like each mask, which is actually 2 raised to the power n time it would take, and for each mask you are iterating n times to the entire array. So it would take n into 2 raised to the power n, and space would be 2 raised to the power n, because there are total 2 raised to the power n subsets. Okay, so if you guys have still any doubts, you can reach out to us in the comment section of the video. And also I would recommend you guys to do this problem, that is subset second. And if you're getting doubts, the video is also present over my channel. You can refer to that also. And yes, do not forget to like this video, share this video, and subscribe to our channel for the latest videos. Thank you for watching this video.